Hello and welcome to the 6 trig functions video. It is my hope that you already know about 3 of these functions, but the other 3 may be a little bit more of a mystery. So we're going to spend some time focusing on the 3 that we do know, where they come from, how they help us in our unit circle, and then we'll be introducing the last 3. I do actually have a copy of this on Canvas, the blank note, so feel free to pull that up and follow along. So when we think about trig, we're first usually introduced to trig when we hear the phrase so ka toa. So what does SOHCAHTOA mean? Well, the O, the A, and the H stands for opposite, adjacent, and hypotenuse, and the S, the C, the T stand for sine, cosine, and tangent, meaning our trig functions. Trig functions are really just ratios of different sides. So this SO stands for sine of some angle, let's call it theta, is equal to opposite over hypotenuse. The ka, or cosine of theta, is equal to adjacent over hypotenuse. And then the toa, or tangent of theta, is equal to opposite over adjacent. Now, when I'm talking about this opposite, adjacent, hypotenuse, what am I talking about? Well, I'm talking about the sides of a right triangle. So if we have a right triangle, like so, I'm thinking in terms of my angle. So I'm going to place my angle right here. So when I'm thinking of my O, or my opposite side, that's going to be on all the other way, on the other side of my right triangle. So this would be my opposite side. The hypotenuse is always the longest side across from the right angle. This is our hypotenuse. And the adjacent side is the other side next to the angle. That's how I always think of it, because adjacent means next to. So this is our opposite, adjacent, and hypotenuse, and sine, cosine, and tangent are just the ratios of all of these and moving around. So we've been spending some time with our unit circle over the last few days, talking about different angles and learning about that. And we also spent some time drawing some triangles. So what I'm going to do is I'm going to rough sketch a triangle here, and let's draw some triangles in it. But first, I think I'm going to take this information. It's a little cramped in the corner, so I'm going to write it underneath down here, just so we can see a little bit more. So I'm just going to rewrite everything we have on the side. So let's see, we have, oh, that's in blue. There we go. Let's get it in black. So we'll have SOHCAHTOA, and we'll have that sine of theta is equal to opposite of hypotenuse. Cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. So I'm rewriting it here because I'm going to be writing a little bit more based off that. But let's draw ourselves a circle. I'm going to zoom up. We don't quite need our table yet, so I'm going to draw ourselves a circle. I think we'll have the blue, so let's see. I'm going to do some real rough sketching here. Okay, so rough sketch, there is our unit circle, and I'm going to draw myself a triangle there. Oops. I'm going to draw myself a triangle, something like this. Okay, so here's a point somewhere on the unit circle. I've drawn a triangle based off of it. It's now a right triangle. Here's our angle. So it kind of looks just like the triangle that we have over here. I've now just placed it on a unit circle. So I'm also going to be labeling my sides adjacent, opposite, and hypotenuse as well. So this is going to be adjacent, opposite, and hypotenuse. But remember, this is the unit circle, so we can kind of think of this slightly differently. So our adjacent side is really along our x-axis, so these are our x values. Our opposite side, or that height, is really our y values, and our hypotenuse, that's just the radius, or r, of the circle. So if I was to rewrite sine, cosine, and tangent using x, y, and r, I could say that sine, instead of opposite over hypotenuse, is my y value over that r. But the radius of the unit circle is 1. That's why it's called the unit circle. So I can say that sine is really just the y value on the unit circle. For cosine, I can say this is, instead of adjacent over hypotenuse, x over our radius. But again, the radius is 1, so x over 1 is just x. And then for opposite over adjacent, for our tangent, well, our opposite side is y, and our adjacent side is x. So we can have y over x. The reason this is really cool is because we already know a lot of this information on our unit circle. This is the coordinates. So if we come back up here, I can see, okay, my sine of theta, that's really my y values. So if I take a look right here, I'm asking for what is sine of 0 degrees or of 0 radians. Well, the y value at that point on the unit circle is just 0. So that'll be 0. Now I might ask myself, okay, what is sine of 30 degrees or pi over 6? And that would look something like sine of pi over 6. So make sure that your theta always goes inside that parentheses. Well, if I think what is my y value or that height at pi over 6? Oh, that's 1/2. So I don't even have to do any solving. If I know my unit circle, I can fill all of these out. So at 45 degrees or at pi over 4, the y value is root 2 over 2. At 60 degrees or pi over 3, sine of those angles or the y value at those angles is root 3 over 2. And at 90 degrees or pi over 2, the height is 1. So we were actually able to fill all of that out for the first quadrant just because we already know our coordinates. But let's try it again for cosine. Now remember, cosine is just our x value. So now I'm asking myself, what is the x value for this angle? So for cosine of 0 degrees or cosine of 0 radians, that's going to be 1. For cosine of 30 degrees or cosine of pi over 6, we're going to have the same answer, and that x value is the square root of 3 over 2. At 45 degrees or pi over 4, the x value is the square root of 2 over 2. Cosine of 60 degrees or pi over 3 is going to be 1/2. And lastly, our x value or cosine of 90 degrees or pi over 2 is going to give us 0. So we've already filled out about 1/3 of the table just directly from our unit circle. So we can also actually do tangent from this because we know that tangent is y is equal to x. Pardon me, not y is equal to x, is equal to y divided by or over x. Or if we bring it back down to where we were writing earlier, since we know that y is sine and x is cosine, we can say this is also the same thing as sine of theta over cosine of theta. So if we take the time to go, okay, what is our y value over our x value? That's going to give us our tangent. Lucky for us, we already have our table situated so that we have our y value over our x value. So here, 0 over 1 is going to give us 0. So tangent at 0 degrees is 0. If we try that over at 90 degrees, 1 over 0, nope. Sine over cosine, 1 over 0. You're not supposed to divide by 0. That's really, really bad. So tangent at 90 degrees, or tangent of pi over 2, is undefined. And that's okay, because again, we're not allowed to divide by 0. Let's try this again. So if we try this at 45 degrees, our y value over our x value. There's a lot going on here, but really what we have is something divided by itself, and anything divided by itself gives us 1. So tangent at pi over 4, tangent of 45 degrees, gives us 1. The other two get a little bit trickier, so I'm going to try those just up here. And then we'll move a little bit lower. So for the rest of tangent, let's take a look. So if we're going to do tangent, let's do this in blue. Tangent of 60 degrees, let's do that. So if we do tangent of 60 degrees, that's going to be our sine over our cosine, or root 3 over 2 divided by 1/2. So from here, there's a few different things you can do. You can write this the long ways, cancel things out, do what you need to do. But I also know that if I have a fraction being divided by another fraction, and both their denominators are the same, I can cancel them out. I'm just going to be left with the square root of 3 over 1, or square root of 3. So I can say that tangent of 60 degrees, or tangent of pi over 3, is just going to be square root of 3. Let's try this once more with 30 degrees, or with pi over 6. So tangent of pi over 6 is going to give us our sine, or our y value, over our cosine. So again, you can write this the long ways, multiply by the reciprocal, do what you need to do. But again, two fractions being divided by each other, if the denominators are the same, we can cancel those out and be left with 1 over square root of 3. The problem is we're not supposed to have a square root in the denominator. So I'm going to rationalize the denominator and multiply top and bottom by the square root of 3. That way, when I find the denominator here, square root of 3 times square root of 3 is just going to give us 3. And then 1 times square root of 3 gives us square root of 3. So I can rightfully say that tangent of pi over 6 is square root of 3 over 3. And there's half our table. But what about the other half? When I taught AGS 2, I'd always have some students, at the very end of the year when we were learning about SOHCAHTOA, I'd always have some students go, okay, so I see these, but like, what if I flipped them? Like, why isn't hypotenuse ever on top? What do we do there? Well, that's exactly what we're going to be talking about. These three trig functions have reciprocals called cosecant, secant, and cotangent, and we're going to be spending some time with them. So the reciprocal of sine is cosecant, and we label that as CSC. So again, cosecant is the reciprocal, or 1 over sine of theta, which for us is 1 over our y value. So if we know sine, we can find cosecant. Similarly, the reciprocal of cosine is secant, or SEC of theta. And that's going to be 1 over cosine of theta, or 1 over our x value. So if we know our x values of our unit circle of those coordinates, we can find secant. And then lastly, the reciprocal of tangent is cotangent, or COT of theta. So since that's the reciprocal, that's going to be cosine of theta over sine of theta, but you can also think of that as 1 over tangent of theta. But in terms of our x and our y, that's going to be x cosine over y, or sine. So if you know the coordinates of your unit circle, if you know your x and y, you can actually find all 6 of these trig functions, or the answers to all 6 of these trig functions. So we're going to spend some time filling out some of the table. I'm going to leave the rest for the Go Formative tomorrow. So let's try at 0 degrees, or 0 radians. So we're finding cosecant of 0 degrees or 0 radians. Remember, that's 1 over our y value. So in this case, 1 over our y value, oh, that's 1 over 0. That's not good. Okay, so that's going to be undefined. Okay, done. So let's try secant. Remember, secant is 1 over our x value. So if we do 1 over our x value of 1, well, 1 over 1 is just 1. Okay, not too bad. Let's try cotangent. Now, cotangent is our x value over our y value. So it's kind of the opposite of what we did before. So it's going to be our x value of 1 over our y value of 0. Oh, 1 over 0? Not good. That's going to be undefined. And there you have it for your 0 degrees or 0 radians. Let's try at the other end of the table with 90 degrees or pi over 2. So cosecant of 90 degrees, remember, is going to be 1 over our y value. So 1 over 1, that's just 1. Okay. Let's try that with secant. So with secant, again, is 1 over our x value. So 1 over 0, dividing by 0, you're not supposed to do that. So 1 over 0 is going to be undefined. And then for cotangent of 90 degrees, it's going to be our x value over our y value. So our x value, cosine, over our y value of sine, 0 over 1. That just leaves us with 0. So we have 9 more squares to do. I'm going to do 3 more with you. I'll leave the other 6 for the go formative. So we're going to do all of the column right here at 30 degrees or pi over 6. Now I'm going to be going through and showing all of my work, kind of how I'd like you to show it when you're working on the go formative tomorrow. So let's start with cosecant of pi over 6. Oops. There we go. So let's see, cosecant of pi over 6. Well, cosecant, I know, is 1 over our y value or 1 over sine. So I'm going to turn this into a sine problem of 1 over sine of pi over 6. So sine of pi over 6, that's something we already know. That's 1/2. Whenever I'm asking you to find, let's say, sine of pi over 6 or cosine of 3 pi over 2 or something like that, you don't have to show me the work for sine or cosine because it's already on the unit circle. But something like its reciprocals, like cosecant, this is when I'm going to want to see the work. So now that we're here at 1 over 1/2, you can write this the long way. You can multiply by the reciprocal, but also 1 over any number just flips it. So 1 over 1/2 becomes 2. So we can say, am I still recording? Yep, something popped up. So we can say that cosecant of pi over 6, if we go back to our table, is just 2. Let's try this again. So let's try secant of pi over 6. Well, I know that secant is 1 over cosine, so let's turn this into a cosine problem. We're always going to want to change everything into either sine or cosine. This is 1 over cosine of pi over 6, and I know that cosine of pi over 6 is going to be the square root of 3 over 2. So like I just said, we could take our fraction, we can write it the long ways, or we can just flip it. So I know this is going to be, keep hitting something, 2 over the square root of 3. But we have a problem because we know we don't want to have a square root in the denominator. So we're going to take an extra step and rationalize the denominator by multiplying top and bottom by square root of 3 and getting 2 times the square root of 3 over 3. And it's kind of a messy fraction, but that is our answer. So we can say that secant of pi over 6 is equal to 2 times the square root of 3 over 3. And that's what I'm going to write in our table. Lastly, let's try cotangent of pi over 6. So I can turn this into something with tangent, but I'm going to turn this into cosine over sine. I'm in the right color. So that'll be cosine of pi over 6 over sine of pi over 6. This is kind of what we just did with tangent earlier. So this is going to give us the square root of 3 over 2 divided by 1/2. And again, anything where the denominators of both of our fractions are the same and we're dividing them, we'll just cancel them out. We're going to be left with the square root of 3 over 1, or just the square root of 3. So we can say that cotangent of pi over 6 is the square root of 3. Now we have a few pieces left of the table to do. I'm going to leave that for you to do as part of the Go formative for tomorrow, and there'll be also a few more questions on there with sine, cosine, and tangent, just so we can practice. Stop by my office hour from 11 to noon if you have any questions, and make sure to also watch the combination day 2 and 3 video tomorrow for homework.